speaking of, using Wasm and WASI, as an operating system, so I think, it's a good time that we introduce our good friend Bailey, to talk about a new advancement in WASI. So there seem to be great progress has been made in the past couple months. So Bailey, please, yeah.
Let me share my screen.
Mhm.
Um, okay, can you see that okay?
All right, yes.
Excellent. All right. So yeah, we've made a ton of progress. I will say that this effort in a lot of ways started since 2019. And I will be giving you the current state of the world. Just know that between 2019 and now, there was a lot of evolution and a lot of changes. And so sometimes that can mean that things may seem a little weird. So I'll try to highlight those everywhere that might have happened. So I'm talking today about WASI P2. I will go into some of the different naming stuff on the next slide, but effectively, this is that next iteration of WASI Preview 1 that came out in 2019. And as you're probably familiar with, WASI Preview 1 gave you the ability to run WASI outside of the browser because it provided a monolithic ABI that said, hey, here are all basically the syscalls that I need to make to be able to be successful, to compile programs that can run. And this Preview 2 has basically all of those same interfaces exposed within WASI CLI, but there's actually some new stuff that's pretty cool, and I'll highlight some of those. This vote was held January 24th. I'm the WASI co-chair. And so I got the honor to basically hold this vote, and some of the phase process and stuff with standardization can be confusing. I included a link to it, but basically what it meant is that it had progressed to a level that was stable. We had two effectively definitions, WASI CLI and wasi-http proxy, and then those also had two reference implementations, one allowing it to run in Wasm time, and the other being able to run it in Node.js, which is pretty cool. And this is one of those things that I was going to highlight that might surprise folks, because if they remember what WASI Preview 1 was, which was very much about running outside of the web, this is now very much about running everywhere. That's one of the key differences between WASI Preview 1 and P2. So the name, it's kind of confusing, right? We don't love that we've kept that preview name. We knew Preview 1 was pretty far away from an MVP, pretty far away from what we wanted. And so giving it the preview name was trying to put up all the flares, like we're definitely changing this. And it might really change. But the reality is that as we've been iterating over the years, we've come up with something that's super stable, that's versioned, that is adaptable too. And I'll dig into a little bit how that works. But basically, we've got something that can continue to live on, and we want people to build in production with this. So we've always been calling it WASI Preview 2 because when we started in 2019, the next thing would be the next iteration would obviously be from Preview 1 to Preview 2. But that does not inspire confidence. It does not inspire people to want to build on it. So I'm working with Dan Goman to propose a different name, which if you listen to me, I call it WASI P2. And the reason why is that it's kind of like WASI point 2. This third bullet here is what it basically is. So I really hope that that part changes. The next part that's kind of confusing, and you'll see in a bit, you might not think that wasi-http, for example, an HTTP interface is something that would fit in the category of a systems level interface. And once I show you some of the other interfaces that are in the pipe, like wasi-cloud with a key value interface, and you're like, that's definitely not a systems interface. And so we already have a proposal to rename WASI to stand for WebAssembly Standardized Interfaces, basically common interfaces that we go through an open standards process that lets us define a set of interfaces that let us run in whatever target environment we want to target. And so speaking of target environments, we have this definition of what we call worlds. And in P2, there are two worlds. There's WASI CLI and WASI HTTP. WASI CLI is very much like WASI Preview 1 with some extra stuff that I think everybody will be into, including sockets. So if you've been dealing with WASI Preview 1, you'd be excited to see sockets. There are some other additions. So wasi-clocks, for example, doesn't have it yet, but will soon have time zone information in it. So there are different pieces here where each one of these individual interfaces, wasi-io, clocks, random, file system, and sockets, themselves are modular. And so a single world, you can imagine a world being a lot like a profile in that when I compile to WASI CLI, I'm saying I'm targeting the CLI world. I want to run as if I were a CLI. And that means that I export a run function and I have imports for things like this. I basically want to run on a kind of a POSIX-like system. And the other part here, I included the portability criteria in that to be able to say WASI CLI is ready and part of P2, it had to be able to run on Windows, Mac OS, and Linux. Emphasis on Windows here because that was not as easy as it might seem. And then it also had two complete independent implementations. WASI HTTP is this other one that I kind of consider a little bit more of a high-level interface. Not so high level that I necessarily expect users to code directly to it. WASI HTTP, what I hope to see with it is that it shows up in all the major standard language libraries so that when you target WASI P2, and then you can just use the built-in HTTP client that's inside the standard languages. So an example would be if I'm building with TinyGo and I'm targeting WASI P2, and then I'm also able to use net HTTP module. And I don't really necessarily am writing stuff that says WASI, all those things, because the WASI HTTP API itself is very verbose. And it's verbose necessarily because to work really well with other people embedding clients across all these different standard language libraries. So those are the two worlds. One last thing that's important to recognize about WASI P2 is that we are allowing other worlds to show up for, the next, I would say about, 10 months before we have the next major breaking iteration, and that's going to be P3. What goes inside P3 is for supporting native async. The way that we do that today in P2 is all inside this wasi-io interface, and it's got this primitive type called a pollable. It also has support for streams. So those two things basically work in a lot of ways like callbacks inside the host that supports wasi-io. It's got this table of all the pollables, and so it knows how to help you do async work effectively. And so the goal is to push this down into what we call the canonical ABI. And I'm going to hit on that in a little bit next. But first, just to inspire confidence, the Wasm time implementation, one of the reference implementations, it has this giant test suite. We did reuse the same test suite for verifying the Jco and Node.js implementation. We're actively also working with Jco to also make it work really well for browser environments. But there's some tricky bits around the fetch API that was a lot easier to solve inside Node.js, and that's why we don't have it immediately today, but it's getting worked on. I hope to see it in the next couple months. But yeah, tested all these platforms, so we're feeling pretty good about it being portable. Now, there's this other word that I've been avoiding a little bit, and that's components. So within WASI P2, it's built on top of this new thing that we created that's almost like a new language in a lot of ways, but it builds on top of all of the existing core WebAssembly specs. And so as you can guess, a component is composable. I'm able to compose two components together. And it really is metadata that wraps around a core WASM module or multiple WASM modules. And one of the reasons to support components in this way is that I'm able to make it language interoperable so that I can have a Rust component talk to a Go component. But the way that they talk to each other is through these imports and exports, which are high-level interfaces, those same interfaces that I was showing before that we standardized for WASI, but these could be your own interfaces because one of the main changes inside P2 is to support modularity. So you can design your own, which is really valuable for a lot of folks that want to design new things. And so the third key property that components build on top of existing WebAssembly properties is that it supports fine-grained sandboxing. So basically, each component has its own linear memory. For a runtime to implement components, it also has to support basically the multiple memory proposal. And so when I compose two components together, component A and component B, I get out component C. And component C knows how to instantiate both of those two subcomponents. This is cool in that you can do things like saying, I don't necessarily trust component B because that's some third-party library from my business logic in A. So this diagram I created with Kate Goldenring. Now the next diagram here, this is Kate's diagram showing off one of the ways that you could use components. And so we gave a live demo of this at Wasm Day, at our last Wasm Day. And what we did is we took an authentication middleware component. You know, this was just what's a common component everybody has to deal with in the cloud native space? Well, that's probably one. And then we were able to compose them together and then slot them into a WebAssembly host. And WasmTime has the serve function that makes it really easy for you if you have a component that targets the wasi-http proxy world, then you can run WasmTime serve with it and then be able to run it. You know, pretty much vendor free, which is pretty nice. Jayco's got another kind of run trick, but I'm not as good in JavaScript and Node environments, so I didn't mess with that, but in theory it works. And yeah, so this is kind of that nice composability. And so you can imagine that these components can have any number of them in it. And so, so long as the WebAssembly host supports those imports, basically, so the host itself exports those things. Exports are these kind of like little nubbins here going up like a Lego brick. That's an export, and then the component itself imports that. So in this case, the component is importing wasi-cli environment, and the host is exporting wasi-cli environment. And so that's how it's able to slot in. So you might be wondering, hey, what's the key difference between a module and a component? Well, not a ton, actually. The main difference that I would show is that a component basically wraps a module or multiple modules with high-level interfaces. And the interface that I picked here was totally on purpose. I'm showing off that the logging interface allows me to pass in a string. And if you've messed around with modules before, you know that you kind of have to have an agreed upon way of taking the string, the way that it's done in Python or Rust, and it's different per language, and stuff that into your core module inside as I32s. And so because we have basically these high-level types now, when I compose two components together, there's this part of the system called the canonical ABI that lets me compose them together so that I know how to lift and lower types going from core WASM module types to the component level definition of those types and back down again to that other component. And that is how I have language interoperability. That's the key here, and that's what this enables. So let's say we crack open a component, like let's look like what does it have under the hood? So that import for logging, see it's the downward nubbin, and then that export of run is the outward nubbin. But the reality is that what's inside, it's still a core module, and it's still all the same core WebAssembly specification stuff. And it takes advantage of being able to use multiple memories so that you can have multiple core WASM modules and components that talk to each other. And so if I were to run this component on any of the systems that exist today that support components, I would get the exact same performance profile as if I had a single core module, because all the compute is still right there in that same core module. Now, this is like that part where, you know, hey, I'm the CTO at Cosmonic. And so one of the things that I work on, I'm a maintainer of WasmCloud, which is another CNCF project. And Cosmonic is the managed version of WasmCloud. Well, we support 0.2 right now, P2. But there's another key part of why you should trust us when we say it's time to move to P2. And that's all these interfaces are versioned. And not only that, they support multiple versions at the same time. This is that superpower that lets us move as if it was a peninsula of stability, in that if you start working with P2, we can now move you along into the new versions, let's say once P3 is available. And that's extremely powerful. It's something that we really had trouble doing before. There's a reason why 2019 was the previous iteration of WASI, because when you have one single monolithic ABI, it's really hard to grow it forward because you have to have agreement across everyone, everywhere. Whereas this is like, actually, I need to hold a vote for Blobstore. And that's the only thing I'm checking. That's the only thing I'm verifying. And Blobstore moves independent of everybody else. That's really nice. And so the trick of how we got modules to support components is that we have this thing called an adapter. We call it the WASI Preview 1 adapter. And so if I run the command wasm tools component new, taking a single WASI Preview 1 module, I can output a new .wasm that has that component metadata around it. And it is adapted itself with a WASM module, which is kind of cool. But it's a special kind of adapter that knows how to take those previous APIs and then match them to the new ones. And we can continue to do this type of technique as we grow the interface. As we change things, we can continuously add more adapters without the end user ever having to recompile their code. Right? You give me a compiled artifact, a .wasm, and then I can continue to adapt it forward in the future. And so platforms are pretty excited about this, because that means that our users necessarily don't have to deal with this problem. When they recompile, they get the new stuff and it's all great, but they don't have to. Our platform can support it. I've hinted on this a little bit before, but right now we are at WASI P2. It's stable. It's starting to get integrated into all the language SDKs, which means basically many years of support is ahead of us for WASI P2. The next addition is WASI 02.1. And we expect throughout the year to have several more of these. And it'll add things like forwarding and splicing of streams, time zone support I mentioned for wasi-clocks. I think we'll have several more additions that we'll add that people are really excited about. Personally, I'm really excited about dictionary types. So if we get those dictionary types in, we're going to create, it's purely additive. I do want to highlight that non-breaking changes only, so that it's backwards compatible. But by the end of this year, the goal is to have a new iteration of the component model that supports native async. And what that'll effectively do is take most of the stuff that's in wasi-io and merge it down into the component model so that wasi-io doesn't really have much of anything in it anymore. But that itself will be the breaking change. However, we'll be able to continue doing our adapter technique to take folks that are on P2 and adapt it to P3 without them having to recompile their code. So that's pretty cool. And then after that, we're building towards MVP, and we're on the path to like official standardization. And that's why we're still giving it the major version 0, because we know we haven't quite hit the MVP of what we want to build with all of this. At the bottom here, I highlighted some of the different other worlds that I'm aware of that people are really excited about. wasi-cloud's one of the ones that I work on. wasi-NN has been around, but there's a lot more that folks want to do there, which is cool. And then some of the new stuff, I've been hearing about people being really interested in different types of hardware interfaces. And so there's one idea being floated that's like, well, maybe we need sort of an embedded world so that you can target an itty bitty place. Then for WASI Web GPU, sort of the same idea. Like, let's build something that helps us target graphics applications. So that is a little bit on the WASI backwards compatibility. I tried to make this pretty quick. I know that there's a lot of depth here. So Michael, you said you wanted to hold questions to the end, so I can just stop sharing now.
Yeah, thank you, Bailey. I definitely learned something today. That's so are you really saying that we can start a HTTP server in the browser now?
Kinda, yeah, with
Okay.
hacks. So the way that it works is, I said hacks, shims. That's the word that these JavaScript people tell me they use.
Okay.
So inside Jcode, they've got this piece called WASI shems, and that piece is actually mostly JavaScript glue that kind of like funnels it so that your code says, "Oh yeah, I'm an incoming handler. I just work with stuff." So when you get called, you handle things like you would handle it with any other HTTP. So it's not quite like a server, but a proxy is very much how I would describe it.
That's definitely would be really interesting because one of I'm sure you have seen this a lot at Cosmonic as well. A lot of people wants to start web servers in Wasm like they used to do in Java, right? So so to have the HTTP interface everywhere, I think it's really valuable. And in the past, we would have to patch and manipulate those common libraries in different languages in order to do that. But I'm really excited to see a potential new way to have this built in as a standardization and a path forward. That's yeah. Thank you for your great work in this, and we also look forward to supporting the preview tool and the component model, and to have something to demo fairly soon. Yeah, that's
Yeah,
um,
that's going to be a really fun workshop. I can't wait to
yeah.
watch it, you and Brooks.